Okay, it's 6 o'clock. Let's get started. Hey everybody, welcome to week 3 of Advanced Programming with Java here at Portland State. Let's see here, we got a bunch of stuff to cover tonight. Let me sort of run through it real quick. So first, I want to have like Prime Minister's questions. So I want to hear about Project 1, stuff like that. We'll talk about Project 2 right off the bat. I didn't get to that last week because we were all pretty exhausted by the end of the night, so let's start off with that. I want to talk a little bit about Maven's site and some of the documentation stuff. There's been a bunch of questions about it. Normally I would have gotten to it already, but we've been really focusing a lot on TDD and all of that, so I want to spend a little bit of time talking about that. Then something new. I want to talk about pair programming. I want to talk about code katas, because that's what we'll be doing tonight. We'll be learning about pair programming. We'll be hopefully seeing some pair programming and then experiencing it ourselves as we work on what are called code katas, little programs to help you and a pair learn about Java. And then also I want to talk about Project 3. That'll be plenty for tonight. So start off with what can I tell you about Project 1? How are the cones going? Any sort of general questions or observations that you've had about working on Project 1? So everybody submitted it?
No.
I saw a couple people, no, not yet. Okay. Just remember the late policy is you get 2 late days to use for the term. We're already into the first late day, so you can submit between now and 6 p.m. tomorrow. That's 1 late day, and then up to Friday. That's your second late day. But what's most important to me is that you submit it. And so then even if it's like, tomorrow at 8 o'clock, get it in, and we can, worry about it. But most likely, it'll be okay. So if you're going to stress about something, stress about getting your code to work, not necessarily getting it in on time, because I'd much rather have the graders grade a working project, even if it's a little late, than having one that's like completely blown up, because that's just frustrating for everybody. So, okay. Oh, I guess I wanted to ask, how did you do things? Did you write automated tests for it? Did you find both unit tests? Most people write unit tests. Good. The integration tests. Did that make sense to you guys? Yeah. Was it helpful? How do you feel about your confidence in your programs? Saw a couple thumbs up. Yeah. Pretty good. You'll find out later this weekend. Yeah, okay, fine. Yeah. Well, and that's why I encourage you to use to have automated tests, because it gives you proof that yep, it's doing at least what you think it should do. And then we'll find out when I put it through my test cases what I think it should do. Cool. Cones coming along. Saw some questions about them. Okay, good. Work's starting to pile up and stuff. So just keep making steady progress on it. And I think you'll have no time. I guess, is it due next week? No, week after next. So yeah, you guys know. Yeah, right. Okay, so due in a couple more weeks. Okay, anything else on Project 1 or the cones? Okay, let's talk about Project 2. We didn't get to this last week. Okay, so Project 1. Really the goal, or the meta goal of Project 1 was to get you used to working with the environment, right? And there were lots of questions about it. I saw this in IntelliJ, or how does Maven do this? Or, okay, it works fine on my machine, but then something strange happens on the CS department machines. Yup, that's par for the course. And that's really why Project 1, I hope you found, was pretty straightforward from a programming standpoint. Yep, got you some command line parsing and got to work in Java, maybe doing some stuff you hadn't done before. But that was really about getting you used to the environment. Project 2, things start getting more interesting. And in that, now in Project 2, you'll be using the Java I/O APIs to write the contents of an airline, including its flights, to a text file. So you'll take your Project 1 and you'll augment it with a couple of new classes that, again, are all in your package. There's a class called TextDumper that implements an interface that I define called Airline Dumper that basically takes the concept of an airline and dumps it to a text file. So that's what text file does. Now the format of the text file is completely of your choosing. right? I'm not going to tell you what the text file should look like, although I guess I do want to stress it has to be text. I don't want to see binary. I don't want to see, even if it's, I mean, if you can figure out how to do like, JSON or XML, that's cool. I need to, or actually the graders, need to basically be able to understand your text file enough so that they can prove to themselves that like when you add a flight to it, a flight has been added. So other than that, we don't care what the text file format is, and actually that's part of the assignment. It's for you to figure it out. So a text dumper takes an airline object and writes it out to a text file. Text parser goes the other way. It will take a file, parse the contents, validate that the contents is valid, and then from that file, build an airline that represents the airline and the flights that are stored in the text file. So I/O to a text file. There's also a new main class, a class with a main method called Project 2 that is basically, it provides the same command line interface as Project 1, except for there's one new option, which is -text file. And so -text file specifies the text file to which, from which the airline should be read, and then to which the new flight that's specified here on the command line should be written. Note that text file is an option. So if it doesn't appear on the command line, it should have the same behavior, same lame behavior as Project 1. So you're adding more functionality, but you're still retaining the old functionality of Project 1. Oh yeah. Okay. So there was some discussion on the community about this. So you need to be able to bootstrap your text file, right? So the first time your program is run, or at least so when your program is run and there's not and the text file doesn't exist, that's not an error. Instead, what you should do is say, okay, great, doesn't exist. That's totally cool. Internally, create a new airline object, add the flight to it, write it out to the text file using the dumper. In years past, I had some projects that came in and they would complain, it's like, the file doesn't exist. It's like, well, of course it doesn't exist. How do I know how to create it? I create it with your program. So that logic needs to be there. And note the dates and times are the same as they were last project. So all pretty similar. Yeah? So
you provide the interface, right?
Yep. Okay. Yeah. And so part of this is learning how to use this this text dumper and text parser interfaces, and the fact that you're implementing it in an interface.
Is that in the same code we initially downloaded from the repo?
Yes. Yep. That's all in the projects jar or whatever, but they're in IntelliJ, or if you just import this class into your when you write your airline dumper, you say it implements text dumper, and it ought to find it. Yeah.
So the documentation for the method is this online from the documentation?
So yeah, the documentation for my class is for the text dumper and text parser, just like for the abstract flight and the abstract airline. So you can go look on GitHub. If your IntelliJ is configured correctly, you should be able to navigate to it, navigate to the source in IntelliJ, and probably even look at the Java docs in IntelliJ. Yep. Yep.
So for the read-write, the write's pretty obvious. You supply the arguments, and then it goes into the file. For read, are you just meaning bring it into memory when you load the program?
It being the file?
Yeah.
So yes, I mean you can imagine what your text parser does. It somehow receives either a file, or if you watch the lecture on I/O, you'll see Java has this whole class hierarchy for dealing with I/O, in particular text-based I/O. So there are some classes that you can use that will abstract things like, hey, I've got something that contains a bunch of lines of text, or I've got and then you can figure out how to create something that says, great, I've got a bunch of lines of text that come from a file. And you can compose all these objects to do cool things like that. So that's part of the assignment too, is to learn how to use those APIs for reading text and then writing text back to files. There's something else I was going to say, and now I don't remember. It'll come to me. Yeah.
So, I just want to clarify that if we pass the option text file and no other arguments, it's just going to read the text file.
And no other arguments. No, because arguments are required.
So
yeah.
If we are giving a file and giving the airline info, why does it need to read it from the file if we are giving it to it as an argument?
So what the program does, good question. What the program does is it adds flights to an airline. Okay, and in your project 1, it did that, although you had no way to tell, right? Because it all added in memory and the program exits and poof goes away. Now we're making it persistent. So when you specify a -text file, what you're doing is adding a flight to the airline stored in the text file. So read it in, because that way you'll have the existing flights, add the new flight, write it all back out again. With feeling. Sorry.
So here we are dealing with one airline with multiple flights?
One airline, multiple flights, yes. And
Just one airline?
yes, one airline, and the way you'll tell that, actually it's kind of here, the airline name given on the command line is different from the one found in the text file. So it's an error to say, hey, I've got this file that contains, airline A, and if you then have B on the command line, it should be an error. Note that the name of the file has nothing to do with the name of the airline. So some people have gotten creative in the past and said, oh, they should be the same. And I'm like, no, they shouldn't be. And because all your tests fail, and that's bad. So anyway, yes. And these are good questions and the kinds of things that, as you think of them during the week or as you're implementing them, and, please post to the community. A lot of the questions I saw this week I thought were really good ones because, first of all, you guys are coming up with great test cases. So, I think that bodes really well for the way that you think and your prospects in industry. But also, you're asking for clarification instead of making assumptions, and that's also very smart. There was another question. Sorry, Chris, yeah?
I guess just to clarify, so one airline per file.
One airline per file, yep.
My question was, so are we able to print out all of the flights?
No.
So
Project 3.
So we'll only see one flight, but we'll have...
Exactly, yes. Yeah, so here again, baby steps, lame stuff of like, great, now I can add to a file. Now, what I'll do is, what the graders will do is that they will, again, look at your text file, and so the text has to be readable enough. Now, this text file is machine readable, but a human needs to be able to look at it and say, okay, great, I just added a flight, and I can see that a flight was added. So don't encrypt it or anything like that as text. That would be bad. Yeah. Yep.
So program doesn't need to read the info which is already in the file. Just add new info.
You could do it that way, or you could have it conceptually. The way I think about it is that it reads it all in and writes it out again. But you could just append it. Yeah. That would, and as long as it works. Hey, truth be told, I don't really care how you implement it. I'm not gonna, have the. I can't afford to have the graders. We don't pay the graders enough. There you go. To look at 60 different submissions and look at the code and say, oh, you did it this way. Sorry. So get it to work, and that's an important first step, especially if it's well tested. Yeah.
Can you clarify? If there is no file name provided in the options, what's the new file supposed to be called?
It's not. Okay. Well, so you mean if you don't have the -text file?
Like program 1.
Exactly. Without the -text file, just like program 1. So it's like, I don't know anything about no file. I'm just going to create a new, create an empty airline and add a new flight to it. And if -print is there, print it out. Yeah. Okay. Nice. Okay, so that's project 2. Okay. So that is due next week. I think some of you, from the questions that I saw, have already got a head start on it. Good. So we're getting some of the questions worked out. Maven site. So, one of the, let me see here, what do I got here? Let me find a good, there we go. So, we've seen that Maven can do a lot of things, right? And you guys have used Maven to build your projects. So if you watch the Maven lecture, you'll learn all about the various, directory structures and where you put your source code and where you put your test code, and the Maven phases like compile to compile your test code and test to run your tests, and verify to do all this stuff end to end, and package to build your war. And you've been working with those as part of your projects. There's something else that Maven does that I think is really cool. There are all of these tools out there that will do various analyses and generate various reports and things like that on your source code. So, in addition to the Java compiler, which will turn into class files that you can then run, there are tools like find bugs that will go through and do an analysis of your code and look for things that might be bugs. Maybe there is an opportunity that a variable will always have a null value, gee, that doesn't seem right because if you try to use that variable, it's always going to throw a null pointer exception. It's the kind of things that IntelliJ highlights in yellow. So all of those things. But what this is a reporting tool that will go through and just look at the source code. And this is nice because it's independent of the IDE. So like when you're working on your code, great, it's easy to find these things. And IntelliJ will put it right there in your face. But it's nice to have, just the same way when we talked about Travis CI and how you have sort of a build in a clean room environment. Well, this is an analysis in a clean room environment where you can just create a report and put it up there. Similarly with JavaDoc. Right, I mean, we've seen JavaDoc a little bit, and I know a lot of you guys have been working on it because it's required, part of your assignment. But you have your code out there. You can run the JavaDoc tool, and that will analyze all your source code and create pretty HTML pages and stuff that then provide API documentation for your code. And there are all these tools that implement that. So there's a tool that's used for find bugs to do the analysis there. There's JavaDoc for JavaDoc. There's all sorts of other things. And people have written Maven plugins for these tools to integrate them easily into your projects. And just like the same way Maven will download the JUnit jar for you, Maven will download all of the components that find bugs needs and just run the stuff there. So Maven itself, so there are all these plugins to Maven. These plugins are leveraged during what's called the site phase of Maven. So when you think about the life cycle of your project, there's like the compile phase where you build your source code. There's the package, and then there's test phase where you run your unit test. There's the package phase where you build your jar file. And then there's the integration test phase that will run integration tests and then verify, which will do all the setup and teardown for do all the previous steps. Do the setup and teardown around your integration tests, and then make sure that your integration tests were ultimately successful. And then there's things like install and deploy, which will actually get the artifacts out where they need to be. In addition to all of that, you can build what's called the site. And so Maven you can configure Maven to use all these tools. And Maven also has some sort of built-in stuff that will give you some Maven information about your project. Like, here's a list of all the plugins that it uses, and here's a list of all the dependencies, and can tell you things like, oh, these dependencies are out of date and can be updated. This is all really useful stuff, and it's essentially free in Maven. And this is all part of having sort of a mature software project. So it's not just about getting it, no, it's not just about writing the code. It's not even just about getting the code functioning correctly. You also want to understand the quality of your code. You want to be able to share your documentation and the code. And what Maven's site does is that it'll do all of this analysis. It will create all of these reports, things like the results of your unit tests and all that good stuff. And then it packages it all up into a bunch of HTML files and stuff, a website basically that then you can then deploy off and you can deploy off to the internet and have all this information about your project. And because it's Maven, and it means that all projects that use Maven will have sites that contain approximately the same information, and so it's familiar to you. So if you look at a bunch of websites for projects that are built with Maven, they look kind of all the same. So to that end, let's take a look here at the airline. So this is my simple airline application. You guys have implemented more, but this is the one that I've done here. And I'm going to run Maven's site. Now, Maven's site does all sorts of things. First of all, it's going to build the airline and run all the tests, all of that good stuff. But then I've configured it to do a whole bunch of other things. It's going to generate a bunch of reports. So, like for instance, there's something called check style, which goes through and looks at the the coding style that you use. So, are your braces on the right lines, everything like that. It's all configurable, right? It's running JavaDoc to generate the API documentation. I think also along the way, it I lost my ability to scroll in this thing. Wait, has it? Edit. What was that? View lab mouse reporting. I don't want that. There we go. But I lost my... Okay, anyway. And I think it also ran some code coverage, just I wanted it to. Anyway, so it created the site. And then I think I need to say Maven site : stage. And what that'll do is it'll package up the HTML files in a way that... that's neat. In a way now that can be opened nicely from the site directory. And then if you say index.html, yeah. So now this opens up in a browser. I'm looking at a file here on my local directory. And this whole website, a series of HTML files, has been generated for my airline project. So it's got a nice little about page. And notice that all of this stuff comes from the project itself. So let's go, if we go look at our POM for the airline. So this is the Maven. So for instance, this description right here, an airline application for blah, 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 is right here on the page. So in the POM, you might have seen this, there's all sorts of information about, like, here are the developers, right? And here's who works on it. And here's the URL, and here's the inception year, and all sorts of stuff like that. And this then is all, let's see here, project information. This is all listed here someplace. So, like project team. Okay, great. That information there in the XML file is the reports when the report is generated or when the site is generated. That information is then put here. Stuff like that, and you can have members and contributors and stuff like that. There's some nice boilerplate. And so there's this project information which is all about the Maven-y things, like well, like here are the plugins that are used, and so then you can when you go to use a project, you might want to know some of this information to see what versions of things they're using. Probably not so interesting. Do I have? Okay, here's an example. I told in my POM, either here or in the parent POM. Nope. Some of this is inherited from the parent. I told it that I use GitHub issues for issue management. So like when something's wrong with my project, here's where you go to look. Well, the Maven report, when the Maven generated site, it went and found that and said, okay, great, and I'm going to create a nice HTML page so that anybody who sees it will say, okay, great, here's how I go and I file issues against this code base, against this repository. And here again, so it's like one line in the XML, and then there's all of this mechanism that comes for free with Maven to then leverage what's there. Same thing with continuous. Oh, I guess I didn't set up continuous integration. I need to do that, et cetera, et cetera. So you can find out my license and all of that good stuff. Oh, dependencies. Actually, does that link to the right place? It does not. But anyway, and now you can find out, like, okay, what dependencies do I have? So like, I use so this project uses the summer 2017 version of my projects jar. And you can find its license. Also it has, JUnit for test, all sorts of other stuff like Hamcrest, good things like this. And this is all important when you go and make your project publicly available. Or maybe even internally, depending on how large your organization is. But this is all good stuff to know about people. This helps people be able to use your project. Also of interest are these various reports. So I was talking about all those tools that have Maven plugins for that will do code analysis. And so this, the output of those tools gets bundled here in this project reports section. So I'll just look at a couple of them. So there's this tool called Find Bugs that will go through and complain about things that, or not complain, will bring to your attention things that might be a little smelly. So luckily it's only found one of them. It's here in my project one, and it's a dead store of abstractairline.class in the main. Okay, I can click on the line here, and it will open up a report that helps you, makes you that shows your source code, and it says, oh yeah, right, it highlights line 11, where sure enough, there's this dead store, meaning that I assigned something to this variable C, and I never do anything with C. Why are you doing this? This might be a bug. It also tells you it gives you, lets you get more details about what this bug really is. So like dead store of class literal, and it tells you things like, oh yeah, by the way, the behavior of this changed between Java 1.4 and Java 5. And so Find Bugs is really cool because there is this ever-growing database of things that Java developers have come across that were surprising, right? And so if someone's out there and hey, I'm using Java 9, there's really weird behavior, people should be warned about this. Then they contribute back to Find Bugs, and then you can use Find Bugs in your code, and you're like, oh wow, look, I just went to Java 9 and oh, this behavior changed. That's pretty crazy. So anyway, it lets you find out about all of these things. And here again, the whole idea is that the stack analysis is meant to help you find bugs before your customers do. Or your grader, or the grader, right, in your case, yeah. So that's find bugs. That's really cool. There are all these tools that are built in. Cobra 2 are test coverage. So remember, I think last week we ran the test coverage tool in IntelliJ, and that was neat. Well, here's a report that can be run by Maven, or rather, Maven runs a test coverage tool, and now you can see. This isn't very interesting. You can see which lines are run and which ones aren't. Oh, maybe if I had run it on student, I'd get something a little bit more interesting because student has unit tests. This doesn't. This has very simple unit tests, and so all it does is call get number. But anyway, so if you ran on yours, and I believe you get all of this stuff because all of the configuration for this is configured in like my top level POM, which all of your projects is the parent project for your projects. So I believe you get all of this stuff. I saw some people trying to run the Java doc. Has anybody run Maven site? A couple people. And did you see this kind of stuff when you ran Maven site?
Yeah.
Okay, cool. Good. So this isn't required. It's not going to be in the exam, but it's something that I encourage you to play with, right? To see what's there, to see what it can do.
What's the command?
Maven site, S-I-T. It's mentioned in the.
Put up automatically as an index.
Oh, sorry. Yes, right. So Maven site will generate the site, and then if you want to look at it locally, you say Maven site : stage, which stages the HTML so that it can be viewed, and then that will put an index.html file in the target site directory. So target, remember, is like, here are all the generated artifacts. They go in this thing so we can blow them away all easily, and then it's in the site directory underneath that. What else is fun? Oh, and here's your Java docs. And so here they are. And we saw some of this the other night where you can now navigate into your API documentation. So anyway, and the cool thing is that, or the thing that I think is cool is that this kind of like just works and it's all magical because and this is one of the benefits that you get by following the Maven conventions. One of the criticisms of Maven is like, oh, I don't want to do things the Maven way. I want to have different named directories, or what if I have to do that? It's like, yep, that's very true. Maven is pretty rigid. They were basically saying, hey, listen, if you do it the Maven way, you'll get the benefits of the Maven way. And so this is one of the benefits that I see. Any other questions about the reports, the kinds of things that you can do with the reports? One more thing I wanted to show you here. Okay, so so this is cool. I've generated this site. I can view it here on my local machine, but that's not what I want to do. That's not very interesting. What I want to do is I want to put it up on some place that everybody can see it. So GitHub has this feature called GitHub Pages, where basically what you can do is you can, for any repository, if you create like a gh-pages branch, that sort of serves as a website for that repository. And so then one of the things that I did I do it over the weekend? When did I do that? Is I configured the parent POM here in the repository for this summer to, here it is. I won't go into the details. You can go look at it if you want. I configured it so that when I deploy the site, I deploy it in a way such that it will be displayed, that is viewable through GitHub. So then if I go to David Whitlock.github, Goldman Sachs. Okay. Yeah, so I go to this URL. So like I've got, let me back up a second. Well, so I'll show you this. So for every repository in GitHub, someone star my repository so it shows up at the top. You can have a branch called gh-pages, which contains like an index.html and stuff like that. Right? And that then corresponds to this content will be served up via this URL. So it's your GitHub username.github.io. So this is github.com. But so it's like username.github.io /repository name. So here's the repository name. and then it's served up there. And that's where the index.html is. And so I'm able, like in one command, just to easily deploy this whole website. Yeah. Daughter's got piano lessons tomorrow. That's annoying. I can deploy my website really easily off to GitHub, and now here it is available for the entire world to see. So kind of cool there. And I guess another thing, you probably won't be doing this, but I've got multiple, as you may recall, in my project for the summer, in my repository for the summer, I've got multiple projects. And then Maven knows how to handle multiple projects, and so then in this in this site, I've got multiple projects here, and so like here's where I can look at that's the cones. That's probably not so interesting. I probably want the student project, and now when I well, let's see here. Now if I look at like the code coverage reports, I'll see I've got a lot more. So now I can say, oh great, I've got 94% code coverage because actually I've automated tests for this here, and okay, for whatever reason this line, interesting. So this line only has 80% coverage, but anyway, this will help you. And like here I don't have a invalid GPA. Huh, interesting. Oh yeah, because this is an unreachable statement because it'll print error and exit. So anyway, you can run all of this stuff on your Maven project, and it sort of all works out of the box. Those of you who are having problems running Maven site on the PSU machines, did you ever figure that out? No?
Yeah, I think it was the Java version.
It was a Java version, yeah, using OpenJDK. Yeah. So let me speak to that briefly. So Java's been around forever, and Java was initially developed by a company called Sun Microsystems, and Java became really popular, and there were a lot of people that are calling to open source it because Sun's a company, and the Java community was worried that something would happen to Java if either something happened to Sun or if Sun decided that they wanted to start pulling it in. And so then Sun eventually said, yeah, the right thing to do is to start open sourcing things. So Sun was then acquired by Oracle, and Oracle now owns Java and stuff. However, so there's this open source project, version of Java called OpenJDK, which has most of the class library is open source as part of OpenJDK. Most of the Java virtual machine and most of the tools and stuff are available, but there are differences between the two. And especially when it comes to tooling and the locations of various executables and stuff like that. So I'm old school. I go with the Oracle JDK, but I think for many of you guys by default you get OpenJDK, and it works fine. 85% of the time. I think a lot of you guys though are hitting some of that 15% difference in things like running the Maven site and find bugs. So I need to think about if I want to do something about that in the future, like maybe try to enforce, or I don't know how exactly to find out whether or not I'm running OpenJDK or Oracle, and then tell you about it. But anyway, good. Glad you got it figured out. If you're still struggling with it, try configuring with Oracle JDK instead. Okay. Maven site. Yeah, exciting, right? Okay, fine. Cool. So all sorts of neat stuff that you can do there. What's next? Let's talk about coding katas. Code katas. Oh, this is like a very long article. Okay. Anybody here study a martial art? So karate or yeah, okay, Chris. So a kata, and make sure I got this right. A kata is a little exercise that you do, a certain flow, a certain sequence, particularly in a martial art, and it's usually something that is done in front of a group or as a group. And so then there's this concept called code katas, where the whole idea is that more so than a cone, where a cone is like a very little piece of thing, a kata is a smaller program. So there's some functionality there. There's some end-to-end stuff, but it's meant to teach you something about programming, or here's how you solve a program in a particular language. Well, I'll get to that. I'll get to the coding dojo at the end of class. But one of the things, and I found and so there are all these like programming katas out there on the internet that are good for teaching people about a programming language or a certain aspect of a programming language. And I found that they're good tools for this class. They're probably about the right level for people like yourselves that are familiar with programming, that maybe know a bit about Java, but are still figuring out how to express things in a language using the APIs to do so quickly. And so then what we'll be doing this week, and then probably for a couple more weeks, is we'll be working with these. We're working with a kata to give you experience, kind of working. Usually with a pair or in a group on a little problem. And so unlike and this is your opportunity to collaborate with other people. So unlike your projects where it's all your own work, this is an opportunity for you to work with other people to see how other people learn and maybe get some new ideas or some new tools in your toolkit for how you can write Java. So you can go read that webpage, probably much better than I could read it to you. So we'll be working with some katas, and we'll see one tonight called FizzBuzz. But the way we'll be working on these katas is through pair programming. Oh, I just remembered I didn't plug in the audio yet. So we got to find the audio. Got the audio? Yeah. So let's watch a video all about pair. How many of you have heard of pair programming? You can probably guess. Okay, most people have. Anybody ever experienced it? Ever done any of it? Yeah, Chris, a couple other people. Yeah. At school or professionally or summer camp? What? They don't know anything about that. Not quite yet. So, so let's see here. Let me volume up. Okay. So this is a video that comes from North Carolina State University that talks about pair programming. It's super cheesy, and that's kind of on purpose. That's the way I like it. But I think you'll sort of get the gist here quickly.
Hello and welcome to Fun with Pair Programming, an introduction to pair programming for students. If you're a student who is new to pair programming, you've come to the right place. This video will help provide valuable information to make you the best pair programmer you can possibly be in your classes and beyond. Pair programming refers to the practice whereby two programmers work side by side on one computer, collaborating on the same design, algorithm, code, or test. The pair is made up of a driver who actively types at the computer or records a design, and a navigator who watches the work of the driver and identifies problems, asks clarifying questions, and makes suggestions. Switch roles from time to time to share the work evenly and get the most out of your pair programming experience. You'll hear effective pairs constantly chatting as they jointly decide how to tackle the task at hand.
Well, actually, I don't even know where it's saving this stuff. So we create a new patient and it adds record. Oh,
right.
Probably in save data file. Mm-hmm. So it's going through, looks like a list of records.
Mm-hmm. So we probably, since we just added the height and weight, I don't know if that's actually getting written.
Yeah, probably not.
Okay.
So
why do so many thousands of students around the world prefer pair programming? Why don't we ask some to compare old-fashioned solo programming to this new and innovative system?
Wait, what was the word?
You would program by yourself, so you'd usually be just by yourself in a computer, maybe in a cube or at a single desk, and it's a very lonely type thing. It can be.
Well, it could be really frustrating. You'd sit there banging your head against a desk and
trying to find, the missing bracket, or couldn't figure out why the logic in your program didn't quite work right. And with 2 people there, it's a lot easier to work those problems out a lot more quickly, so you're not frustrated all the time.
This is nothing new either. Most science labs take advantage of lab partners and small groups. Computer science is no different. You can learn a lot from working with other people. Students find it helps them get better scores on programming projects. Pair programming helps them learn, so they get better grades on exams as well. Mostly, students report that they enjoy getting to know the people in their classes better. This makes it much easier to interact when problems do arise, because you've got a class full of friends instead of strangers. Last, but certainly not least, students are much more likely to figure out solutions if they've got someone to brainstorm with, and this can lead to faster completion times and a better understanding of the subject matter. Students often find the whole experience much more enjoyable and less frustrating. Pair programming will also help you prepare for your career in computer science. In the professional world, people collaborate and pair program all the time, and as an expert, you'll already be ahead of the game. Have you ever spent most of your class time with your hand in the air, getting nowhere on a project while you wait for help from your professor or lab instructor? With pair programming, those days are history, and you'll find yourself having a lot more fun. Who knows? Maybe you'll even look forward to the alarm going off in the morning so you can get to class. Now that you know the basics, let's look at some simple do's and don'ts of pair programming. First, be sure to talk. Not a minute should go by when you're not communicating somehow. Don't say anything that might insult your partner. Even if you're only joking, he or she might take it personally. Don't forget to listen, too. Both the driver and the navigator should be fully engaged in the project. So much so that the driver can pass the keyboard to the navigator at any time, and he or she will be ready for the switch with no questions asked.
Periodically switch positions so you can gain experience in both roles.
Switching helps prevent errors and stimulates conversation, too. Be patient. Be prepared to explain yourself to your partner, and don't get frustrated if they don't understand it first. By explaining your work to your partner, you'll be helping yourself learn as well. Remember the ancient Chinese proverb, "To teach is to learn." And be sure to give the driver a little time to correct his or her own mistakes. After all, no one likes a backseat driver. Respect your partner. The golden rule is key here. Just remember to treat your partner with the same level of respect that you expect from him or her. It doesn't matter if they are from another culture, an introvert, an extrovert, a procrastinator, or the valedictorian. We are all here to accomplish one thing, and everyone has something to offer. Take breaks. You can get more done in 1 hour pair programming than in several hours by yourself. But this can take a toll on your brain. Don't forget to take a break every so often to keep yourself fresh and energetic. When you return, you'll likely see something you overlooked before. Be prepared. Be sure to do any preliminary work ahead of time, and don't be late for appointments with your partner. Their time is valuable, as is yours. Hygiene. Think about it. How would you feel if the person you were going to spend a couple of hours with smelled terrible? Take a shower, brush your teeth, bring some mints. You know the drill. Have fun! Working with someone else can be a lot more fun than working by yourself. You can share a laugh, relieve some tension, and have someone to celebrate with when you get that last test case to pass. Believe me, that's a great feeling. Now that we've gone through all the things you should do as a pair programmer, let's go through some of the things you should avoid when working with your partner. Don't be a keyboard hog, or think that just because your partner is a novice and you're more experienced, that they won't bring something to the table. Don't constantly tell other people what to do either. You don't want to be the only person in the class that no one wants to work with because you're too bossy.
There is another side to that coin, so don't be intimidated. Some people are afraid that they don't know enough, but chances are your partner feels the same way, and you both know way more than you give yourself credit for. Trust me, it will all be fine. The primary goal of pairing is to work together towards the best possible solution, so don't be afraid to speak up if you disagree with your partner from time to time. Your partner may as well be working alone if you're not willing to speak up. If you're unhappy with your pair programming situation for any reason, don't hesitate to talk to your professor or teaching aide. That's their job, and they will be happy to help you resolve whatever problem you may have. As you can see, there are many benefits to pair programming, but there are also a few speed bumps. Sometimes you'll find it difficult to find time in your schedules to meet, for example. But students all over the world agree that the benefits outweigh any drawbacks that they can find.
If there's two of you working on it, typically you're spending a lot less time working on it, so this is great for homework. Then also I would say that in general, your solution is going to be better.
So if you're working with somebody and their grade or their deadline matters to you, you're more likely to get your work done at an earlier time. Also with pair programming, you can typically have higher grades on assignments. There's higher quality code as well.
This concludes our journey through the exciting world of pair programming, but there's still much to learn. Take these tips with you into your next pair programming lab and join the growing number of pair programmers across the country, the world, and beyond.
Okay, enough of that. A whole minute of credits there? Okay. So yes, admittedly cheesy, but I think it gets the point across. And this is geared at students, and although pair programming in the real world is a lot like that, especially the hygiene part, make sure everybody's smelling good and everything. But really, what I've found and what others have found is that with pair programming, it really is two heads are better than one, especially if people really embody those two roles, the driver and the navigator, right? The driver has their hands on the keyboard. They're the one that's thinking about the language, thinking about the syntax, thinking about what things, what things should be named. And then the navigator is sort of thinking about the big picture. It's thinking about, okay, what's the next test that I need to write? Or, okay, how should this, how should the responsibilities be spread out across multiple classes? Or what are the opportunities to refactor? And when you get a pair that is, that is in sync like that, that can collaborate well, you get really high quality code, and you don't need to have like a big peer review afterwards because you already had two people collaborate on it. So I'm a fan of pair programming. It's something that I want you to, or I'd like you to experience here in the course. So here's what we're going to do. We are going to, and I post about this on the Google, on the Google community. First, to give you an idea of what it's like, I'd like to invite any volunteers. I want to pair program with me in front of the class. We're going to set up right down here. We'll use my computer. And the CS department shelled out $25 or something and got us a whole bunch of USB keyboards of varying quality, as I recall. I haven't used them in a year, so we'll see if there's any like small rodents living in them or whatever. You'll see what I mean once you open them. But I also know that I like the keyboards because it means that someone that you don't know isn't touching your keyboard. Anyway, so we'll do that down front. In the meantime, here's what I'd like you to do: spend a couple minutes looking at the kata, because I'm going to rely on you, the audience, to help us with some of the test cases for it. And let's take like 15 minutes, so spend 5 of those minutes reading over the kata, maybe jotting down a couple of test cases. And meanwhile, I'll get set up with like a GitHub repository and stuff like that, so we can code here on my machine. Sound good? Okay. I'll just stop the recording, and oops, come on, babies. There we go. Stop the